Hi everyone. So the next thing that we're going to look at here is radical equations. So these are a little bit different. These are equations that have radicals already in them, such as a square root, and not, say, a polynomial equation or a quadratic equation where you may use a radical to solve the problem. In fact, it's just the opposite. We're going to be doing a lot to get the radical away from what we're doing instead of introducing more radicals. To solve a radical equation, a radical should be thought of as two things. In a way, it's a grouping symbol mixed with an operation, right? The square root is an operation to take the square root of a number, right? Square root asks what times itself, in the case of the square root, 2 times, 2 copies, will give me said result, okay? So doing that is an operation, but it all is also a grouping symbol. So that r plus 10, think of that as in parentheses, generated by that radical. So we have to make the radical go away before we can subtract 10 from each side. So you should not be taking things out from underneath the radical. You have to get rid of the radical first. So in order to do that, just like with any other operation, we're going to do the opposite. So in this case, the opposite is the second power. So we're going to cancel that out. I get 64 equals r plus 10. The r plus 10 doesn't change. So what I always say in class is that the radical kind of catches the second power before it gets to the numbers underneath. So that does not change, but the 8 does become a 64. And then after that, you just go ahead and do what you always do with equations. Do your inverse operations, subtract 10 on each side, you get 54 is equal to r. To check your answer, you're going to do the same thing that you always do. You're going to go ahead and plug your answer back into the equation, and you're going to get 8 equals 54 plus 10 is 64. We know the square root of 64 is 8, so that is the correct answer. Okay. Sometimes you will have something attached to the radical on the outside. This has to be gotten rid of before you square both sides. So I'm going to divide both sides by 2. 2 goes away. I'm left with the square root of a equals 5. And I'm going to square both sides. So just like before, and a would be 25. Okay, I'm not going to show you how to check that one because it's the same as the last one. So if you have operations underneath a radical, those have to be gotten rid of first. Okay, outside of radical have to be gotten rid of first. If you have things underneath a radical, add, subtract, multiply, divide, those would have to be gotten rid of after the radical is gone. Okay. All right. Same idea here. So we're going to subtract because that's outside the radical. So I would get 9 equals the square root of 81x. Square both sides. I get 81 equals 81x. Divide both sides by 81. And I would get 1 equals x. Okay. Now, with this, just keep following this pattern. Outside, do the inverse, get rid of it first, square both sides, get rid of anything underneath. Okay? Alright. I want you to try this one, so hit pause, and then hit play when you're done, and we'll go over the answer together. The answer here is 3 equals m. Same thing, I added 7 because that's the opposite of negative 7. Squared, then divided. Alright, this one is a little bit different. This one is a little bit different because we have a radical on both sides. The nice thing here is because the entirety of both sides of this equation are underneath the radical, we still can just square, right? Because technically the radicals are alone on the side of the equal side that they're on. And the nice thing is that just goes away, and we're left with the terms underneath, which we would solve the same way we always do. So I would get negative 1 equals negative 1r. Divide both sides by negative 1. and I get r equals 1. Now this one you really should check. When you get radicals on both sides, you can sometimes find what's called extraneous solutions, which are, and you've seen this before, answers that you did all your math correctly, but they just don't quite come out to be right in terms of the original equation. This is very true of radicals because we have strange rules with radicals, right? Such as the rule that we cannot take the square root of a negative number, but we don't have with, just plain operations. The other thing that we can sometimes have and see quite often also, not in problems like this, but in others, you might have more than one possible answer, and one might be right and one might not work. This one does work, though. You get the square root of 9 equals the square root of 9. You don't have to make them both 3, right? As soon as we know that the two sides are the same, we get to stop. Same idea here, so hit pause and hit play when you're ready. Alright, so this one ends up being a equals negative 3. We're going to check. Now again, especially this one. This, as soon as you see negative answer, right away, just tell yourself, I got to check it. Just because chances are, if you find that extraneous or invalid solution, it's going to be in one like this, where you end up with a negative answer. So you get negative 2 times negative 3 is positive 6, plus negative 5. And then we would get negative 2 minus negative 3 is negative 2 plus 3. So I would get negative 5 plus 6 is positive 1, the square root of. And then on the other side, negative 2 plus 3 is also positive 1. So that one is valid. Now, if you only have one possible answer and it turns out not to work out correctly, then that equation has no solution. It's just not possible to find an answer. Okay? This next one that we'll look at is fairly more complicated than the previous ones, but not horribly so. So we'll take a look at that here. The reason I say it's not horribly complicated is it's nothing that we've not done before. The difference is we've just not done it together, okay, what we're about to see. So, same rule as before, got to get the radical by itself, add n to each side. I have n minus 4 equals the square root of 13 minus 4n. The radical is now isolated, so I can raise both sides to the second power. I get 13 minus 4n on the right. The left side, remember, is a binomial, so I have to use either the shortcut, which is what I'm going to do, or write it out twice and FOIL it. But either way, it's going to be a trinomial when I'm done. So I'm going to square the first term, n squared, multiply the two together, negative 4n, and double my answer, negative 8n. And then I'm going to multiply negative 4 by itself. So I'll get positive 16. Now, same issue as the last one, not the last one we did, but the one before that. You have a situation where you have the trinomial in the right and left when we put them together. Okay, so we've got the quadratic term n squared, we've got the linear term n, and we've got a constant. So that means factoring or quadratic formula, but I'm not going to put them all together. Okay, I'm going to put the trinomial on the left because n squared is positive, and I really don't want to try to find out what happens if it goes negative. And so I'm going to subtract 13 from each side as well. So n squared minus 4n plus 3 equals 0. This one is easy to factor. Negative 1 times negative 3 gets me positive 3. Negative 1 plus negative 3 gets me negative 4. Zero product property. N minus 1 equals 0 and n is 1. N minus 3 equals 0 and n is 3. Now for this, again, we have to check, and we're going to check with the original equation. So before I move that negative n over. Negative 4 equals negative n plus the square root of 13 minus 4n. Let's do the 1 first. Negative 4 equals negative 1 plus 13 minus 4 is 9. Negative 4 equals negative 1 plus 3. And that is definitely not true. Negative 4 is not equal to, that would be positive 2. This is an extraneous solution. Let's do it with the 3. Negative 4 equals negative 3 plus the square root of 13 minus 4 times 3. So I would get negative 4 equals negative 3 plus the square root of 13 minus 12. Negative 4 equals negative 3 plus the square root of 1, which is 1. Negative 4 equals negative 3 plus 1. Well, that seems a little bit strange now, doesn't it? Because we know that negative 3 is negative 4, is most definitely not equal to negative 2. Well, in looking at this, so this would lead us to believe there's no solution here, but let's just check over our work quickly. So we squared. So going back all the way to the beginning, we added n to each side. N was positive. Good. Squared both sides. 13 minus 4n stayed the same. Good. N squared minus 8n plus 16. That's exactly what we should have had. Good. Added 4n to each side. Got positive 4n. Still good. Minus 13 from each side. Got positive 3. Still good. N minus 1 and n minus 3. Well, let's just check, make sure we factored correctly. I'm just going to very quickly FOIL this. That would be n squared minus n minus 3n plus 3. Nope, that's correct. N minus 1 equals 0 and n is 1. Good. N minus 3 equals 0 and n is 3. Good. So, our math was correct. I know I talked rather fast through that, but just wanted to reinforce that we did do correct math here. So, let's take a look at our check. Maybe we checked something wrong. Negative 4 equals negative 1 plus 13 minus 4 times 1. 13 minus 4 times 1, 13 minus 4 is 9. And we have the negative 1, the negative 4. And that is correct. So that doesn't work out because negative 4 is most definitely not equal to positive 2. And we have the same issue here. This equation has no solution. Okay? And that's what that looks like. So we got answers. We got 3 and 1, but they were not correct. They were not valid. They didn't work. Okay? All right, I'd like you to try this one. This one, whoops, I went back by mistake. This one has 2 correct valid answers. So started out the same way as before. We add n to each side. So I would get n minus 1 equals the square root of 7n plus 13. Square both sides, that gets me the quadratic. N squared minus 2n plus 1 equals 7n minus 13. Put it all together, n squared minus 9n plus 14 is equal to 0. Then n minus 7 times n minus 2 equals 0. Both of those multiplied together to give me 0. At least one of them has to be 0. So then that would make n 7 or 2. When I check, both come out negative 1 equals negative 1. These are both valid answers, and that can happen too. You can have 2 extraneous solutions, which means there is no solution, or you could have 2 correct answers, valid answers, so this equation has 2 possibilities, or you can end up with one of each, as we've seen before. All right, this one, same thing, we'll do it together. So we've got the v, so we'll add v to each side, and you'll notice whenever I do this, I tend to always write it in standard form, meaning the v is going to go in front of the 2, just to have it. Square both sides again, so I get v plus 32 equals v squared plus 4v plus 4. Again, I used the shortcut there, but you are more than welcome to FOIL. I'm going to subtract v and 32 from each side so that we've got equals 0. And again, I'm going to do that because v squared is positive, and I don't like to try factoring things where the leading coefficient is negative. Should be a negative now, and that would be negative 28. Okay, so the factors here I'm going to still keep factoring as long as I can. It's 4 and 7, so that would be positive 7 and negative 4. Right, because negative 4 times 7 is negative 28, and negative 4 plus 7 is positive 3. So that would mean v plus 7 is 0, and v is negative 7, and v minus 4 is 0, and v equals positive 4. Okay, and then we got to check. So we would do negative v plus the square root of v plus 32 equals 2. We'll do this first with the 4. So we would get negative 4 plus the square root of 36. Actually, I don't need that big square root there, equals 2. Negative 4 plus 6 equals 2, which is valid, so that's good. Let's do it again with the negative 7. So negative v plus the square root of v plus 32 equals 2. So we've got negative 7 in both cases. Positive 7, double negative cancels, plus the square root of 25 equals 2. 7 plus 25 does not equal 2. That one is the extraneous. So there's an example of one of each. All right? You try the last one. And this one, we once again have one extraneous and one valid answer. So I added n to each side, squared both sides. So we ended up with 44 minus 2n equals n squared plus 4n plus 4, and that way very similar to the last problem. Then we factored, got everything to the same side and factored n plus 10 times n minus 4, so n would be negative 10 or positive 4. Negative 10 is not a valid solution, does not work out in the original equation, but positive 4 does. All right, so that's it with radical equations. Thanks for watching.